Alright guys, so this is going to be the second video that I will be making. We're going to go over master assignments, over mistakes that students make, and what errors and what hard coding is. At the end, I will be giving you some tips to save yourself some trouble while doing the assignments. Also, there's gonna be a quiz again for this video, so pay attention and I will tell you the answers during the video. So I will be using the same prompt, the same MA that we used last video. So the first thing that I want to go over is coding errors. So let's say that let's say you used the wrong equation, let's say right here or something like that. If you use the wrong equation for one of the calculations in this MA, you would get the wrong answer. You would get values that are off, and then you will be losing points because you used the wrong equation. You're getting the wrong numbers. That's self-explanatory. That makes sense. That happens anywhere. But what's different in this class is because you're coding, there's a potential chance that you might get an error, and by getting a coding error, then that will change the whole way we grade. That will change that will change how we grade your code, and that will affect your grade a lot more than a coding mistake. So if we go ahead and let's say here we name the variable new mass, and that's an input from the user where you're gonna input a mass in kilograms, right? And then right here we're calculating the user inputted potential energy. So we're getting these values, and then we're using that value in those values in the variable new PE to calculate a potential energy. So if we run this code, it works perfectly, and our potential energy will be 123.48, right? 123.48. So let's say I go back and change the name of my variable after I coded everything, right? Let's say I coded everything, it works perfectly. At one point I went back because I wanted to check some things out, and then I changed this variable to mass instead of new mass. This variable doesn't exist, right? We didn't write anywhere mass equals something, right? So MATLAB doesn't know what this is. So we go ahead and run this code, and I put the same values in, you're gonna get an error right away. And this makes sense. MATLAB goes through each line, gets to this line, and says, okay, let me see what mass is. Looks back up, and it says, hey, mass doesn't exist. So if mass doesn't exist, then it tells you undefined function or variable mass. So whenever you get errors, the first line will explain what the error is about, and it's gonna be this. At least this explanation is really simple and really good. I mean, it's just undefined function or variable, so you know that there's a variable called mass somewhere in your code, or in line 32 of your code, that hasn't been defined before. So it has no information, and MATLAB have no idea what this is. So now, the important thing to know about errors is, first of all, it tells you the line, so that's where the error is going to be, and it tells you what the error is about, so you go ahead and you can change it. But the way that it affects your grade is also important, because even if this whole piece of code is correct and works perfectly, just because you had an error at the very beginning and nothing else prints out afterwards, when we go here and grade your code, this whole thing, it's going to be zeros, because we can't run your code anymore. Nothing's printing out, we cannot check line by line, so this whole thing is going to be a zero. And if we input zeros for everything, you're going to get a really low grade. Even if everything was perfect, you're going to get, let's say, a 30 because of that error. And we cannot, as a TA, I cannot go back and change this to new mass, because I can tell. I can read the error and say, oh, he messed up, and somehow he doesn't have the new from this variable right here. I cannot go back and change your code. Maybe you can turn in a grade appeal, and your professor will change the variable name and then regrade it, and then it's gonna work perfectly again. But as a TA, we cannot do that, and then that means that you get a really low grade. So pay attention to errors. Try to avoid them, which is also common sense. Try not to submit a code with errors. But I just wanted to explain how it can affect your grade. It's pretty significant because we cannot. If you get an error, we cannot change your code. We cannot test the rest of your code. So that affects you pretty badly. Okay, so the next thing that I wanted to talk about is hard coding, and this is a pretty big deal here in this class, because by hard coding we mean when you, let's say that you have no idea how to calculate average mass, your total potential energy, and your total power, and you're running out of time, and yeah, you just don't know how to do it. So you go ahead and you explicitly put in the values here that you think are correct. We call that hard coding. You're explicitly putting values here without actually calculating in them or even using the data that we gave you. So if you went back to your prompt and you looked at your command window, how it's supposed to look, you know that your average mass should be 529. You know this should be 156 and this should be 20, right? So you go ahead and write in your values. You write in 529.40 and so on. You write here, you write other values. So by doing this, if you went back and checked, then it was, what was it? 156 and 20. Let's just do it like that. 156 and 20 here. If you were to do that, then you hard coded your numbers in. By doing that, every time we print out stuff into the command window, doesn't matter what I put, doesn't matter what menus I choose, menu options I choose, I'm gonna get the answers right here from the MA. I'm gonna get the expected answers because I'm hard coding the numbers in. I know what the numbers are. The problem with this is when we go back to the rubric and change the data sets and grade your code, the same numbers are always going to pop up because they're hard coded, and you're going to lose points. You're going to get 0 points for those values because they're completely incorrect because they were hard coded, and you're not allowed to do that. Even if you do hard code the numbers in, you're just going to lose points because they're never going to change, and that makes sense. So that's one way of hard coding, because you're explicitly putting values in without actually calculating or looking at the data sets. The other way of hard coding stuff is, hopefully by the time you watch this video you know what indexing means, but the biggest issue with hard coding will be indexing. So here we're collecting data, right? We're inputting the data from data 1 and data 2 from your test cases right here. So if I were to run test case 1, I'm saying here that I want to get the first row, second row, and third row, and I want to get every single column in that row. This is called the colon operator, and means that I want to get every single, in this case, every single column in data 1, row 1. This is row and this is columns. So here we hard coded 1, 2, and 3. We explicitly put in the number 1, number 2, and number 3 for row number 1, row number 2, and row number 3. Because on the MA we say that those rows are not going to change. That's mass, height, and time, and that's not going to change. We always going to have 3 rows for this problem, but we're going to have multiple columns, and we say that in the problem under assumptions. We say that your code should work without changes if the number of columns in either dataset changes, and we talked about that during the last video, because we are changing the columns. So in this way that this is coded, it's good. It's flexible. We call it flexible because we're changing, even if we change the number of columns, this code is going to work. If we went ahead and decided to hard code the number of columns, then it's when we get into trouble. So we hard coded the rows. That should be okay in this case. That's a good good use of hard coding. In this case, we're saying, hey, I want data 1 to 3. I want in data 1, I want to grab column 1 to 3, column 1 to 3, column 1 to 3. And then for data 2, we want to grab from column 1 to 5. So in this case, for the first test case, we have 5 columns, so that works. This code is going to run correctly, and you're going to get no errors, right? Because we're talking about 5 columns, and there's 5 columns here. Let's say you got either lucky, or you knew there were going to be 5 columns on the first test case. But if we go to test case 2, when we run test case 2, if we go up here, there's 4 columns. So because there's 4 columns, this data 1 right here, the conversions are not getting, you're not using the last column, so you're gonna get some calculations wrong, but you're not gonna get an error. You're just ignoring the last column, so that's gonna be some calculation mistakes, but you're not gonna get an error. Problem will be here when you're getting, and that's a problem, but a bigger problem here will be getting columns from 1 to 5 when your data 2 has only 2 columns. That means that when I run this program and I put random numbers, I'm gonna get an error. And the error says index in position 2 exceeds array bounds, which means that you shouldn't go over 2 columns, and we're going over 5. Right, so if you go down here, it tells you where the mistake was, and you should know that, well, okay, so it's telling me that it shouldn't pass 2. So I go back up here, I'm like, okay, what is it talking about? Okay, let me check the data set. Oh, it's 2 columns. So if I were to put 2 here, for example, and change every 5 with 2, then it will work. But again, I'm hard coding the 2, so it will only work for 2 columns. So you want to make your code flexible, and that's what we did before, where we put the column operator. So again, this is going to be a problem, and we're going to test your code for this every single time. We're going to test your code, and we're going to check, hey, is your code flexible? Is your code able to, instead of say I want to go from 1 to 5, your code should be able to say, hey, I can go from whatever column you want to input in your data sets. Doesn't matter how many number of columns, from 1 to 1,000. I won't get an error. I will work smoothly. So that's what we want, your code to run smoothly without us making any changes. And again, if you were to make that mistake, then you will get probably 100% on this area, because we had 3 columns and 5 columns. So your hard coding, even though you shouldn't do it, it will work for this section. But if we get to this section and we start grading, we're gonna get an error very early on, and you will only get points for one line of your code if it's even correct. So then that would also affect your grade significantly, and you're going to be dealing with hard coding and indexing the whole class. So it's very important for you guys to understand what we mean by hard coding, because if you identify different ways where we're testing you on hard coding and flexibility of your code, then you can be ready to code accordingly to that. And that's going to be one of the quiz questions: how to prevent indexing errors in your code. And the answer for that will be your code needs to be flexible. So how to prevent indexing errors, your code needs to be flexible. One way that you can change and test your code, so let's say we gave you student test cases right here, right? Like we went over it last video, we do give you test cases, and that's how you get these answers down here with the test cases that we give you. If you go ahead and go to your test cases right here, and then open it up, not on MATLAB, but just by themselves. So I go to data 1, I open it up, and it's going to take me to Excel in this case because it was a CSV file. If I add numbers here, then I'm changing how my data set is, and I'm changing the dimensions. So then you should go ahead and then save that. Let's say you save it and then run that. When you run that, your code should work. So that's how those are different ways that so if I go up here and I open student test cases and I run this, it should work fine because I changed the number of I changed the number of the columns in my test cases, and my code is flexible. So that's a way that you can test your code. Change the dimensions of the datasets that we give you, and make sure you're getting no errors. And then you should know, okay, yeah, maybe now I'm free from hard coding. And sometimes you can even ask the TA, hey, I think I might be hard coding here, or is this hard coding? And then we can give you some advice and tell you, hey, yeah, it is, or hey, you should change this or not. So that's a pro tip right there, changing your data sets. A lot of students don't know that they can do that. They can open, like, you can just open Excel and change your own data sets to test for hard coding. And a couple more things. If you go to your student rubric, we tell you, and we went over this last video, that we're changing the the dimensions of your test case. So make sure that you read over your student rubric and you check to see if we change the dimensions or not. Most of the time, we're 100%. We're changing things to test your code and break it and stuff like that. We're checking for flexibility. So make sure that you're testing and changing your own data sets to test for that, to make sure 100% you get no errors. Um, Other than that, some tips that you should know while doing your master assignments. Make sure that you run your code before you submit it. So right before you submit your code, run it one last time to make sure that it has no errors. Let's say you, before you submitted it, you clicked your keyboard by mistake and added some letters, and then you decided to submit it. When we run this code, because you added some random stuff, you're gonna get an error, and we cannot do anything about that. Even if it was a complete mistake and somehow you added this stuff by mistake and you didn't notice and you didn't run your code before you submitted it, that's gonna be pretty much a 0 on your MA, because we cannot do anything about that, and you're gonna get a pretty low grade. Of course, you can submit a grade appeal, but instead of, like, save yourself some trouble and run your code one last time before submitting it. Make sure that there's no dumb, stupid, like, small errors like this. So one last thing, after submitting your mastery assignment, make sure that you don't open it again, because if we need to go back and there was a mistake with your upload or something like that, and we need to check your original file, we will check for the day that it was modified, the last time that it was modified. So if the MA was due Sunday night and we see that it was opened anytime after Sunday night, then we might not give you credit if we need to go back to the original file to grade it or something like that. So make sure that after submitting on Sunday, do not open your files again, because we will check when was the last time that it was opened and when was the last time that it was modified. If you want to look at your MA again after submitting it on Sunday, just make a copy and mess with the copy. Don't open the original one, because if there was a mistake with your upload, we'll go back to that original one to give you the credit that you need.